Let's use this tool, GeoGebra, to create that construction once again about squaring the rectangle. So we'll just start by drawing a straight line, and I'm going to draw in a rectangle in here. So I want a perpendicular line through A that's perpendicular to that line. Now I might just mark some points for the corners of my other corners of my rectangle, say there and there. Now I need to draw on the other two sides so that this line here will be parallel to that one, etc. So I'm going to pick up a parallel line through C parallel to this line, and a parallel line through D parallel to that one. And so there's a rectangle. So what we want to do now is, can we find the side length of the square that would give the same area as that rectangle? I'm just going to add a point here. So there's my square. Remember what we did? We need to find this point down here. So imagine opening up that side of the rectangle out onto this baseline. So pick this point. Now we need to find the midpoint of A and F. So there's our midpoint G, and then we needed to, from the centre through there, passing through there, and here's our point here. So I could go in and now I'm drawing a square with that side length from DH, and what I'm saying is that that square would have the same area as this rectangle. I'm going to draw in one more line. I want to draw in a line that passes through G and through H, and I'll explain why we need that line in a minute. Okay, so I've just taken that or exported that work out of GeoGebra as a file, and I've taken it into GIMP just so that we could probably clean it up a little bit. So let's just see if we can rub out some of the other bits that we don't need anymore. So now that we've cleaned that picture up again, let's just put some dimensions on here. So let's say we've got a rectangle that's A times B, and then notice that this side from there to there, that would also be A. So from A all the way out to there is A plus B. And so this point here, G, remember we drew a circle that ran around through there with that radius. Okay, so notice that we're going to call that diagonal there, I could call that R, but we're just going to remember that R is equal to half of A plus B. So it's sort of, G is sort of sitting in the middle of that baseline there. Then that would make this distance here, so between there and there, if it's B, between there and there, can you see that this is B minus R? So we want to find this length here. I'm going to call that L. So using Pythagoras' theorem and just sort of rearranging it, I could say that L squared is equal to R squared minus b minus r squared. So notice what L squared would be. Remember that we've got really got a square sort of sitting out here. So L squared, if L is the side of the square, L squared would be the area of the square. Let's see if we can simplify this one a bit. Notice when I expand this out, I'm going to get a minus b squared. When I expand the b minus r squared, I'll have a minus 2br, but the minus is going to make it a plus. And then when I expand out the minus r times minus r, I'll get a plus r squared, but then the minus, I'm going to get a minus r squared. Notice that that r squared and that r squared cancels. So what I've got is 2br minus b squared. Now let's put in what r is. R is a plus b on 2. So that's 2b times r, which is a plus b on 2. Then I've got the minus b squared. 2's cancel. Expand that bracket out. So that's now equal to ab plus a b squared, and here's my minus b squareds. The minus b squareds are 0. I've just worked out that L squared is equal to AB. I've just said that L squared would be the area of this particular square. What's AB? AB is the actual area of the rectangle.